Hey everyone, we're back. First example, g of x equals 3 plus 2x over 1 plus x. Now, I'm going to count on you having your guidelines, these things, ready for this. Let's first of all identify the domain. Identifying the domain will help us with information we'll need later on too. So, I'm going to set 1 plus x equal to 0. I'm going to look for what x can't be, which is actually negative 1. X equals negative 1 is not the domain, it's what x can't be. So the domain is, I'm going to use interval notation, negative infinity to negative 1. You will have, this will actually be a horizontal asymptote. And then we skip over negative 1, but we stay close to it, to infinity. So that just excludes negative 1. So here's our domain. Number 2, this will not simplify. I'm not even going to write number 2. I may not write the step-by-step things that much. It won't simplify, so it means there's no holes. There's not going to be any holes to worry about in this graph, in this example. The y-intercept. Let's find f of 0. So that is 3 plus 2 times 0 over 1 plus 0. 3 over 1 is 3. So the y-intercept is 3. Okay, vertical asymptotes. Now we set the denominator equal to 0, so we know, and I already said this, that x equals negative 1 is going to be a vertical asymptote. Now, as far as the horizontal asymptotes go, before I do that, let's go for the zeros first. The zeros, now that comes from the numerator. Set the numerator equal to 0, subtract 3, 2x is negative 3, and divide by 2, x is negative 1.5. That is the 1, 0 in this graph. Okay, now, horizontal asymptotes. We are in the case where degree 1, that the degree of the numerator is equal to the degree of the denominator. And when that is the way it goes, that is the y-intercept is going to be the lead coefficient 2 of the numerator over the lead coefficient 1 of the denominator. So y equals 2 is the horizontal asymptote that we have to deal with. And let's see. Now we're ready to draw our axes. Okay, I'm going to mark the x-axis here a little bit. Go 1, 2, 3, 4, 5, 6. Negative 1, negative 2, negative 3, negative 4, negative 5. Okay, sorry about that. Negative 6, you didn't miss anything. You can get that drawn. All right, now, drawing my axes, I'm going to mark the vertical asymptote. We only have one, and it's x equals negative 1. Here is the vertical asymptote. And I'm going to mark the 0 that we have, negative 1.5. So we are going to pass through that. I should have put, if you have those notes, we should draw the horizontal asymptote as well. And that is at y equals 2. Okay, let's get the y-intercept on here. That is at right here at 3. Okay, now I consider negative 1.5 here a critical value and negative 1 as a critical value. So I'm going to find f of negative 2 so that when x is negative 2, what is y here? That gives me some ideas of where to put things. So 3 plus 2 times negative 2 over 1 plus negative 2. That's negative 4 plus 3 is negative 1. And 1 plus negative 2 is negative 1. So I'm going, whoops, not there, right here. Negative 2, negative 1 is a point on the line. So I got a kind of an idea what's happening here. Although I am going to find what is it between negative 1.5 and negative 1. And I could have chosen negative 3 or negative 4. I chose negative 2, just left of negative 1.5. Now, between negative 1.5 and negative 1, anything, I'm going to go halfway between them, though. Negative 1.25, because I think the calculation might be a little easier. All right, well, what do we got? Okay, this is negative 2.5 plus 3 is 0.5. And then 1 plus negative 0.25 is negative 0.25. I think if you divide that out, you're going to get negative 2. So at 1.5, negative 1.5, we're down here at negative 2. All right, got a decent idea what's happening there. And then after negative 1, it's up here. And you could put 1 in if you wanted. I think you're going to find something that's fairly close to 2. 3 plus 2 is 5. 1 plus 1 is 2. So you're at 2.5 there. So I think what's happening here is you're down here. With this asymptote, you're down here. And you come on up and curve your way around to that 0. I actually probably should put this more over here. Curve your way up to that 0, and then you approach this horizontal asymptote. So it looks something like that. And then here, I think if you look, you're up here, you're going to approach that asymptote from high and down to this horizontal asymptote like that. I think if you take a look at your graph, and I'm going to let you do that on your own time. Check that on the calculator. And just see how close we are there. I did put those in parentheses. Before you divide, make sure your numerator and denominator are in parentheses. Okay, I'm going to go for the second example next.